So today we're going to have a look at patterns in algebra, and we're going to look at a simple stick pattern, and we're going to come up with an algebraic rule, but really understand where the rule comes from. So before we start, we need to know these questions. How many sticks are in the next diagram? How many sticks are in the 10th diagram? And write an algebraic sentence to describe this system. So our pattern today is this. It's saying the number of steps and the number of sticks that go with it. So it goes for every one step, there's 4 number of sticks. For every 2 steps, there's 7 sticks. For every 3, there's 10 sticks. So our visual diagram looks like this. If we were to build it, we would start with 1 stick, 2 stick, 3 sticks, 4 sticks, and we would build it off of that. And the same goes for the second and the third. So in order to find the algebraic rule, we need to construct a table of values to further explore the pattern. So our table of values, I'm actually going to do number of squares, and then the next one will be number of sticks. And we'll see on our visual diagram that it's every square, there's 4 sticks. So 1 square, there's 4 sticks. For 2 squares, there's 7 sticks. And for 3 squares, there's 10 sticks. So now to find out how many is in the next one, you might notice that in the right-hand column, it goes 4, 7, 10. So they're constantly adding 3. So when there's a new square, you're adding 3 to it. So you could solve it like that, but you need to find out how many sticks are in the 10th term. You can do it like add 3, add 3, add 3, add 3 until you get to the 10th term. But first we would need to know what the 4th, 5th, and 6th all the way up to the 9th term is, so we can add 3 to that. So this type of rule is recursion, where we need to know the one before it. So we found the rule, we can jump to whatever. So when we found the rule, we can jump to whatever number we need to without having to know the terms before it. So I'm going to break up 4, 7, and 10 and kind of talk you through it to make it look a little different. So next to 4, I'm going to put 3 plus 1. And the reason why I'm doing that is because you notice that in our diagram, it has 1 stick, and you're adding 3 to it. And that pattern continues throughout the diagram. So for the next one, we already have this one, so this is our one that we're adding 3 to. And we add 3 every time. So the next one, we're going to do 3 plus 3 plus 1. And for the 10, the 10, we're going to do 3 plus 3 plus 3 plus 1. So there's a way to abbreviate the number of 3's by saying 1 group of 3 plus 1, and 2 groups of 3 plus 1, and 3 groups of 3 plus 1. But when you say 1 group of 3, you're saying multiplication. So you can change that to be 1 times 3 plus 1. So if I have 1 group of 3 plus 1, that would just be 1 times 3 plus 1. And if I have 2 groups of 3 plus 1, that's basically saying 2 times 3 plus 1. And same for the 10, or the 10 place, if I have 3 groups of 3 plus 1, then that's saying 3 times 3 plus 1. So we started out with 4, 7, and 10, but we changed it to be multiplication because that will help us find our rule. So now we can make a rule like this. So if you notice the number of groups of 3 there are, so 1 group of 3, the same number of squares there are. So when there's 1 group of 3, you have 1 square. And when there's 2 groups of 3, you have 2 squares. And when there's 3 groups of 3, you have 3 squares. So now we can make our rule. So for the number of sticks there are, so number of sticks is equal to the number of squares. Times 3 plus 1. So let's go back to our questions. It says, how many sticks are in the next diagram? Well, we found a rule that we could use. So let's see. We can do, how many sticks are in the next diagram? So if we're trying to find the next one, that's 4. So the number of sticks, that's what we're trying to find. So we could put n is equal to the number of squares, so 4 times 3 plus 1. And that equals 4 times 3 plus 1, that equals 13. So the next one would be 13. Now let's look at this question again. We kind of made up a rule on our own. So let's go back to this question. So write an algebraic sentence to describe this system. Well, we could do, if we're saying number of sticks, we could do an n to represent the number of sticks. And it's saying number of squares, we can do an s to represent squares. And then times 3 plus 1. So there's our algebraic sense that we got out of the diagram. So if we're trying to find how many sticks are in the 10th diagram, well, we can just plug that into our equation. So it's saying n, so that's what we're trying to find. S, how many sticks are in the 10th diagram. So remember what I said, number of squares is equal to the number of sticks. So the 10 times 3 plus 1. And that equals 10 times 3, that's 30, plus 1, and that equals 31. So now that we know what our algebraic sentence is, we know that we found an algebraic rule out of it. We predicted the number of sticks you would have in the next term, and we used the rule to predict it.